Another thing we have to look at is adjusting interest rates for inflation. And so we have a couple equations here, this one, and they look pretty close. And so it's useful to kind of walk through what we're talking about in words. The interest rate they give you for an asset is usually not adjusted for inflation, and it's called the nominal interest rate. When you hear nominal, think name, right? That's where the word comes from. If we adjust for inflation by subtracting away the effect of inflation, we'll call that the real interest rate, because that's really what you get. Now, it turns out there's kind of two ways to think about the real interest rate, so that makes it a little more complicated. But I think once we walk through the examples, you'll see. The first is what we call the ex post real interest rate. Ex post is Latin for afterwards. This is what we get after the inflation has happened. So let's see what that is. So the real interest rate there is R, and we find that by taking the nominal interest rate, I, and subtracting inflation. We'll use the symbol pi for inflation. So here's the example. You invested your money in bonds that paid an 8% nominal return. Over the time, inflation was 2.5%. How much did your money increase after adjusting for inflation? Well, we use our formula. We take the 8% nominal minus the 2.5% inflation, and that gives us 5.5% real return, or to be precise, a 5.5% ex post real return. Right? We got 8%, but everything is more expensive now, so we really only increased our purchasing power by 5.5%. The other way of thinking about this is the ex ante sense, where ex ante means beforehand. So we're looking into the future and thinking what we're going to get. So the equation is pretty much the same, but here we're thinking about expected inflation. And so there's a little e there to remind us that we're thinking about expected inflation. You are considering making an investment in bonds and know they pay an interest rate of 3%. If you expect inflation to be 2%, what real return do you expect to get? Well, the answer is 1%. So we're going to get 3% nominal. We're expecting inflation to be 2%, okay? And so we expect our real return to be 1%. So the next thing we want to look at is how we can construct interest rates from these different parts. And here's an important idea. We can think of nominal interest rates as being determined by two separate parts. The ex ante real rate, which is determined by the supply and demand for funds, such as in our supply and demand diagram, plus an amount to compensate investors for inflation. So, in the market for funds, the equilibrium real interest rate is 3%. So suppliers and demanders of funds are expecting to get a real return of 3%. If people believe that inflation will be 2%, that's what they expect, then they would agree to a nominal interest rate of 5%. So they want a real return of 3%. Inflation is 2%, so they're going to make a contract for a nominal return of 5%. On the other hand, if they thought that inflation would be 5%, then the equilibrium nominal interest rate would be 8%. Right? So we've got a 3% real return they want. We think there's going to be 5% inflation, so we add those together to get 8%, which will be the nominal interest rate. Now let's do a slightly more complicated example. You want to get a 3% real return, and you expect 1% inflation. So you agree to a contract that pays a nominal interest rate of 4%. So again, we're in an ex ante world. We're at the start. We're looking forward into the future. We want a 3% real return, but we need to be compensated for inflation. So that gives us an interest rate of 4%. So we make a contract for 4%. However, we were surprised. Inflation over the year turned out to be 3%. So we contracted for 4%. Inflation was 3%. So the ex post real return we received was only 1%. Okay, so our ex ante real return was 3%. We were expecting to get 3%, but inflation turned out to be unexpectedly high, which means we got a smaller real return, only 1%. So we can put this all together to think about the different factors that determine interest rates in the economy. We can think about it being from a risk-free real rate, that's from our supply and demand diagram, and that kind of affects all the assets in the economy because it's from all the suppliers and demanders of funds. To that risk-free real rate, we add an expected inflation term, right? And that's going to be the same again for all the investors, plus an asset premium. And that is the differences across assets will generate differences in returns. Some assets have a lot of risk, some assets have little risk. So these two things are broadly from the macroeconomy. These things depend on the particular asset, and although may again depend on the economy, whether the economy is good or going into recession or whatever. And so we can build up interest rates this way. So here we're looking at interest rates for three securities: a treasury security, a low-risk company, and a high-risk company. The risk-free real rate, remember from our supply and demand diagram, is going to be the same for all three. We'll call that 2%. Expected inflation is going to be the same for all three, 3%. But the risk premium, how much extra we have to give because of the risk, will differ. Maybe there's no risk in a treasury security, that's the US government, so we'll have a zero risk premium. There's a little bit of risk for the low risk company, so we'll say that's a 1% premium. High risk company, okay, there's a fair amount of risk, so the only way investors are going to hold it is if we give them a big risk premium. So we add these together. So for the treasury security, it's 2 plus 3, which gives it a final interest rate of 5%. For the low risk company, it's 2 plus 3 plus 1, which is 6%. For the high risk company, it's 2 plus 3 plus 5, which gives us 10%. So the high risk company's assets will offer a higher return than the treasury securities because of the compensation for extra risk. The usefulness of breaking it down this way is that if we were thinking about, let's say we're analysts and trying to think about what's going to happen to interest rates and prices of bonds and all that, we can think of these three things separately. So we have the risk-free real rate, which is coming from our supply and demand analysis. We've got to expect inflation from the macroeconomy, and then we've got the risk premium depending on the particular securities. And so, for example, if I told you inflation was going to be higher, but nothing else was going to change, well, then we would change this column, but we wouldn't have to change the other two columns when determining the nominal interest rate. So again, it's useful to break these interest rates down into their components so we can think about each of the components individually. Here we have another example. And what that does is this one, instead of a change in inflation, it's a change to the base interest rate. So instead of the old base interest rate of 2%, we have a new base interest rate, which affects all the different securities of 4%. And so we see the old nominal interest rate increases by 2% to give us the new nominal interest rate. And if you wanted to, you could make up your own example where the risk premiums change, but change in different ways, and that affects the nominal rates too.